Owen.
Yeah.
Well, you've just lit up a cigarette there, but Owen, you showed them your experiment then?
Yeah, no worries. I've got a concept or an idea I'd like to put out there. For others that might have more resources than myself, they might be able to refine the experiment. It's similar to Airy's failure. Well, this is expanded on Airy's failure. Just to compare cosmological models and to find more proof for myself outside in reality. Yeah, just to find confidence in models, pretty much. To answer the big questions, or to try to help to answer the questions. Help people to get off the ball. Yeah. All right, well, you can see this one? Karen?
Yeah, we can see that one. Sorry, I said yes. Sorry, yes.
Yeah, sorry. So you're familiar with this concept by now, I hope, everybody?
Yeah, unfortunately, but yeah.
Yeah, okay. Well, the device is, okay, I'll just run you through this. I believe that I've recently invented a device that can help to compare cosmological models and to answer the questions. It's an earth-turned spinner. The application of this invention is to simulate different earth-turn speeds while comparing the movements done to the apparent motions of the stars above and how they're supposed to scale and act accordingly. To be used for the comparison of cosmological models, to be moved over ruled 0-degree surfaces, to be used to compare speed changes on the ground against the stars above. I call the device the TEST, the Earth Spin Turner. Also to be used as a large sextant to collect star, planet, sun and moon sky positions on different meridians. So this is just an example of what the prototype looks like or looked like. The proof against the spinning model is visible with this test and also increases if the stars are said to be further away. The apparent motions of the stars would and should scale perfectly with speed changes, just as focal length changes in lenses do, of course. The motion of the star field would be the same whether close or far, as it does have a constant measurable motion. I'm measuring changes in the Earth's claimed speed in relation to the star field motion, and however far and whatever that star field is, I'm measuring for change. I'm measuring Earth's claimed motions in relation and checking time speed change for percentage in error. Star distance isn't an argument in my mind, but that's just geometry while the test is simulating Earth movement, not star movement. If people want to put the stars further away, they're going to then have to explain how on earth the Earth's curvature changes the meridian angles of stars based on minute movements, while the experiments are being done moving only over flat surfaces, basketball courts, cement slabs. Bringing in non-Euclidean geometry will only further disprove the ball more so. The fact that the test is done over flat surfaces only validates the proof of exactly how the angle alignment of stars and telescopes can and can't be broken in reality and at what speeds. In my opinion, the stars rise and set not because of the Earth's assumed curvature and motion, but because of XY movements, either over or of flat surfaces. Okay, so the theory craft. Are we still sharing slides? You can see these. Yeah, you can see.
Yeah.
So the theory craft. Take my test device or something similar to the equator. If you can break alignment of an equatorial star with nothing more than XY movements north or south, then the Earth and Sun are clearly not moving through the Milky Way at 450,000 miles per hour, nor are they together moving beyond the speeds of the movements attained during the test. Theory craft 2. Take my test device or something similar to the North Pole. If you can break alignment with the Polaris star using nothing more than XY movements, then the Earth is clearly not orbiting the Sun at 75,000 miles per hour, nor is it even moving sideways beyond the movements of the speeds of the movements attained. Take my test device or something similar to the North Pole, take my test device or something similar to the equator. If you can break alignment of equatorial stars with nothing more than XY movements east or west, east to west specifically, then the Earth is clearly not spinning around 1,000 miles per hour, nor is it even spinning beyond the speeds of the movements attained. So it's that's the premise. Now, I've got a few examples. I've been trying to, you're gonna have to screen share again, something else. All right, a few examples would be some videos of, I just have to upload for you. I'll use this one first. This is screen sharing now. Okay, so this is the prototype in use. Just to give an example, it's a bit dark, but the cement slab has ruled measurements on the ground, so I can see how far I've traveled. So that's an example of it in use. A refined version of the device, very similar to Airy's failure, exactly the same without the water. Sorry, it's a bit unorganized. I'll have to show you a video now of
You're doing good.
the best footage I could capture, really. Okay, so this is a video, a webcam I had duct taped to it, to the refined version. I'll just play that now. So this is a star called Formal Hunt in southern Australia. It's a very bright star. As you can see, I'm not moving the telescope at all at the moment, and its axis is locked on the star. As soon as I apply XY movement, did you see it shoot across the sky?
Mm-hmm.
Well, that just shot across the sky when I moved the telescope. Not its alignment, but only its XY movement. I rolled it about 0.5 centimeter to the north, and the star it arched across the sky. It's the best example I could give. I got hit by fog and all sorts of things this night. This would be apparent if the Earth and Sun were both moving 70,000 miles per hour north, in a northward direction. This would be happening to every star that we look at through telescopes. This isn't even using much magnification yet. So I think it's a proof against the heliocentric model, the Earth's spin motion, the Earth and Sun's motion, all sorts of things. I've got another example. I tried to strap a web camera to the top of my car. This is often cited as a proof for the Bohr model, but they only they leave out east to west movements when they cite it as a proof. So my car here, it's aligned to a town directly west of mine. So my car's aligned west along with the road, and I've got a web camera strapped at 90 degrees to the roof of my car. I had to strap it onto the door because the roof was too slippery. The duct tape wouldn't stick to the roof, but okay, see, here's the footage. So west is to my left. If I put my cursor near this star, right now I'm traveling between 60 and 100 kilometers per hour. Cars were overtaking me, in fact. The cars were overtaking me. And you can see this star is declining.
I don't see it yet. I don't see it yet.
Oh, no.
Oh, sorry, we're looking at you. We're looking at you. You need to screen share.
And as much as I'd like to look at you.
All right, I've got it. Hang on. Thanks for the reminder, Karen.
Sorry, it was Mark that noticed it. I'm trying to add the last person to the. That one.
Okay, well, I'll just quickly show this video again. I was the only one looking at it. All right, so my car is aligned west along with this road. Atherton is the town I'm heading towards. It's a fairly flat stretch of road. And here's the camera duct tape to the roof, looking up 90 degrees. Web camera, I've got a laptop on the seat of the car next to me. Okay, I've just got to zoom in on this star a bit now. Okay. I'll probably zoom in a little bit more. I'm just trying to show you this star here now. Sorry if I'm a bit unprepared as well.
You're doing really good. It's the first time you've done it live and everything, so you're doing really well. Don't worry.
Okay, so this is the star, and I've started to, the car's now driving 60 to 100 kilometers an hour. I'll just take that back again. Oh, there's a message pop up getting in the way here. Okay, can you see this star?
Yeah.
Quite dim. I've only got a web camera doing this. Right, so if I put this here, west is left, is to the left here, along with the direction of movement. So my car's traveling this way. This star is declining to the east. which shouldn't be able to occur unless I'm traveling over 1,000 miles an hour. It's take it back, there's a considerable declination, and this is without any magnification as well. So it becomes even more apparent with magnification. Just the gap here, the drift. The only reason I've put this up is so we can gauge how far it's drifted. And I haven't even traveled 10 kilometers. It's probably a 5-kilometer drive going 60 to 100 kilometers an hour. So I find this pretty evident proof. It's just not very good quality yet. Working on better cameras. I could give some more examples for those that don't understand the concept. Okay, this is a game called Astroneer, just to help me explain the concept of what we should be seeing if the Earth is a ball or was a ball ever. It's got a full spherical simulated Earth that you can travel the whole way around and arrive back at your prior destination. So I'm on ground level now on this sphere. It's not to scale with the heliocentric model, but it has the same principles. So if I get in a car and chase the stars to the west, I should see an apparent change in their motions. Either they'd slow down by %, or if I can drive faster than said Earth is supposed to be spinning, they would stop or reverse, depending on those speeds. And as you see here, I cannot really slow the stars down in this simulation. I can't catch up to them because I'm not able to match the angular motions of this planet, the angular speeds this planet's supposed to be doing. So in this model, I'd failed to slow the stars' apparent motions down. Another example is a GIF that I've made just to explain the concept and what we're looking for. Okay, so this car, when it goes 0 miles an hour, it's going with the spin of the Earth. Car speeds up, the car's going 1,000 miles an hour, and the stars have finally appeared to stop overhead. So this is the ball Earth theory, that one has to travel 1,000 miles an hour at the equator to have the star's apparent motion stop or reverse. Or yeah, faster than 1,000 miles before they'd reverse. But yeah, that's the concept. So yeah, the star that in the car test and the focal length test, I used the same star, formal hump. This one here. And yeah, pretty conclusive in my mind. I think that I've learned a lot from playing with this device. When people assume that the Earth might be a much larger spinning ball after seeing things like the Chicago skyline from 60 miles away, impossible, I think. Impossible because the Earth would then need to theoretically spin even faster to explain the sun's 24-hour cycle. And if it were larger than we are told, I cannot even measure the currently claimed 1,000 mile per hour spin speed. The Earth cannot be smaller because people would then question the shrinking oceans and similar distances and smaller distances against the distances that we've all known thus far. Not only that, but measurements of curvature would be more evident. It also has me questioning things like claimed rocket sciences and maths of orbital mechanics, and what was said to have gone into every NASA mission, and how that was said to have been done using the spinning curved heliocentric model. The only conclusion I can bring myself to is that the heliocentric model is outright wrong. Science has been hijacked for monetary gain, and heliocentrism needs to be reevaluated, if not entirely reshaped or abolished. If a hypothesis is proven wrong, the hypothesis law or principle is required to then be changed to remain in the realms of science, otherwise should be abandoned. If people think it's similar to Airy's failure, what kind of crazy person puts water in their telescope? I think that Airy was only trying to make his experiment fancier, to help explain principles and to get people like myself interested in geometry. In my opinion, if Airy did have wheels on his telescope, he knew full well that the Earth was stationary even before he filled it with water. Might be a lot to digest, and I might not have explained it very clearly. I'm not a very linguistic person, but I'll leave some links, Facebook references. I've typed up an explanation, and I hope people can run with this idea and make similar inventions. I'd like to see perhaps a camera locked at 90 degrees moving down a large straight rail or something along those lines to disprove the Earth's 1,000 mile per hour claimed motion. So yeah, the idea's been put out there, refined. Make your own earth turn spinners. Put your own webcams on top of your cars. I mean, actual motions on the ground when compared to apparent motions of the stars above. Just for me, disprove the spinning ball model. We can see, we don't have to make this so technical. We can just look up and see that the stars aren't going south of the ecliptic. So there's, you know, it's just geometry in my mind. I made this just like I thought Airy's made his experiment more fancy, just so people can really look at why and how star distance isn't an argument. They might start to believe their own eyes. Taking it to the geometries of this thing is it turned out really nice. I don't know. I can see all sorts of the prototype, especially. I like looking at the moon, and yeah, I'll just share this one. I can see a crescent moon in there. I can see an enclosed system, a dome, a firmament. Yeah, there's all sorts of things. This claim has been used as a ball earth proof as well. People driving south and a northern star starts declining on a meridian, and they say that's proof of a curved, moving over a curved surface, but really it isn't. If you can also do that on a flat surface, change the meridians of stars.
Right.
I've been able to reverse the apparent motions of the stars with a 1 mile per hour movement, which is just impossible. That would have only, or it should have only changed the apparent motions of the stars by 0.1%, but they not only stopped, they reversed. So yeah, I'm not excellent with maths, but the model has to be wrong by like a 1,000% in my mind. Exactly, and yet you can bring it all the way down to centimeter movements, and you can still. So it's trippy. It's someone's got a 360-degree camera they're using as proofs.
Stan Smith.
Stan, yeah, you sent me the link. That would be a perfect camera for this test, and I think he knows he's thinking along the same line that the stars can move through the sky depending on your own location on Earth, similar to a rainbow. How a rainbow will move around. The star field will roll over your perspective bubble with very small movements. So yeah, it's interesting, at the least. Yeah, it's yeah, a big interest of mine. Quite amazing. Where we live, I can't work it out yet. I have no, I'm not convicted to any one flat Earth or geocentric model, but I'm geocentric because of my own scientific proof of geocentrism. So anyone who's a geo, my love goes out to you.